We have Alex Watila, who is the current chair, maybe for Computer Society Kenya section. Maybe Alex, I can welcome you. You say I want, then you can start the session. Hello, Alex, are you there?
Yes, I am. Thank you, Chris, for setting this up. We are trying to revitalize the IEEE Kenya Computer Society, and we hope this is the beginning of many such kind of events. Thank you, Ezabo, for volunteering to present to us. I hope you all find the session useful. Thank you for joining us.
Alex.
Okay. Thank you very much, Alex. Maybe Ezabo, you can now take the floor and take us through your presentation. Thank you very much.
Okay, thank you, Alex. Thank you, Chris. Let me set up my system shortly, and I share the screen.
Hello, Ezabo, I see you're muted. You are muted from your side. The screen is visible, but you seem muted.
Okay, sorry for that. I was trying to set up the slide. I hope all of you can see the slide.
You can from my side. Yes, visible.
You can see the slide, right?
Yeah, yes.
Okay. Good evening, members. My name is Ezabo Baron, as you can see on the screen. I'm the current chair for IEEE Uganda section. I played in a lot of roles as an innovator and also as a leader. But let me go much into my brief introduction of my innovation side of it. Basically, I was never born a genius, but I was born in the village. I had no idea much about technology until the age of 17, around 2006, when I picked interest in computing, and I took it as a serious career. And then from there, I kept on being like just someone who likes doing things. And then in 2014, I got exposed to robotics through a boot camp. I really liked working with the electronics and all that. And then I joined a robotics a research group in Nakao Vocational Training Institute. It's an institution under Ministry of Education. The program was for benchmarking mechatronics lab by Japan International Cooperation Agency. And the embassy for Japan in East Africa, of course, the one based in Nairobi, the ambassador had introduced our East Africa robotics contest. It's called RoboCen. In Kenya, details about RoboCen programs can be found from NACOSTI, its National Commission for Science and Technology, Kenya, NACOSTIT, Kenya. So they're the one who managed that program. What they used to do is like, I think the program is still there because I've not been with it for around 2-3 years now. 3 years. So what we used to do is annually they gather universities and the technical institutions in East Africa, particularly Uganda and Kenya. They give us challenges to develop robots that solve particular community problem. They can tell you develop a robot which is going to do voting. Maybe like if the election's coming in Uganda or Kenya, you have to develop a robot which will imitate voting processes. It can vote for governors, the presidents, the MPs, and all that without a human control, meaning that you don't have to use a remote control anywhere to guide the robot. But what we're supposed to do is using sensors, we're able to manipulate the robotic motion. And of course, in the task, they don't tell you how the robot will look like, whether it's going to be a drone or it's going to be a rover like the one you see on the screen, the one which can drive, or it's going to be a boat. So as a team, you read through the task they've given you, and then you visualize how the robot is going to be. Is it going to have some arms to pick an object? Because like there are tennis balls placed somewhere representing the candidates, representing the president, the governors, the senators, the MPs. So those tennis balls have colors. They may be yellow, red, black, white. So once you see those tennis balls, you need to manipulate your robotic motion. For that case, you can use the sensors, like color sensors, which can sense the colors of the tennis balls. All that they don't give you in the task, but as a robotics team, we sit down, we read the rules, we read the picture they've given us, and then we're able to come up with our robot. Another thing that the contest used to emphasize is trying to build a robot using local material. Usually for learning purpose, people try to use kits like Lego kits. Lego kits in the early days for that competition, they were working, but later they stopped encouraging them. If you ever go to compete with Lego kit, they will not give you marks. But what they emphasized is that we build robots using local materials. At Nakawa, we have a machining department. So we work with the machining department to fabricate our robot from scratch. And I've seen many of the universities, Dedan Kimathi University, I can't remember all of them, but at least Dedan Kimathi used to be one of the top. Kenyatta University used to be one of those universities, and many other universities. And they used to really, people used to make robots that are so amazing. I have videos in my YouTube channel where you can see some of the robots that we built after this session. So that encouraged, of course, during that, they also used to introduce us to deep learning. We found it a bit advanced by then. That's the first time I got access to in AI. Robotics, Japanese robotics experts used to mentor us on the computer vision because they realized the robots we are developing needed to advance to a higher level where we could use the computer vision to analyze the motions and all that, because we are using a lot of sensors. So they were telling us to use computer vision to like kind of reduce on the sensor inputs. So that's how we got exposed to many of the things. It used to be a full week, and it used to be at the Kenyatta Conference Center. So that's the brief. Of course, that was something we did, and I think the program is there because I'm no longer with Nakawa. So one thing I learned is that that project took me into the world, because it's the same project that made me win an award to travel to United States. And from there, I started seeing several. I had to go, and we presented with things in a UNESCO conference. I was also still presenting about robotics in Italy. That was 2019 through Photonic Society. So that is the brief I can talk about myself. But currently, I'm now moving so much into AI. Robotics is a part of AI, but what you are focusing on may vary. Like I may be focusing on software-based robotics or chatbots or something like that for business communities. But it does not mean that I've stopped doing something to do with robotics. So with those few backgrounds, I think robotics is a great thing. It makes you really learn a lot. Most people are working with hardware, integrating software into hardware, you know, how to program microcontrollers. These are not lessons taught in many universities, but when getting to robotics, you are forced to start using microcontrollers like Arduino, Raspberry Pi, and all that. So there are a lot of resources on YouTube. I mean, we are not taught, but we just have to learn them using the resources. So let's move on to talk about robotics. What is the robotics? Robotics is basically a machine that looks and acts like a human being, but not all robots may act exactly like human being because there's difference in artificial intelligence and some simple automations. So because the robotics can be from simple automation to more complex automations, it has mechanical devices. Some robots have mechanical devices. They have motors, which we're using for manipulating their motion. They have sensors. Like as you can see here, someone is the young kid is holding, or the white thing is holding. That is a motion sensor. They call them they are motion sensors, which are used for detecting objects ahead of a robot. Because if you program the robot, possibility of it knocking objects ahead of it, because like that one I told you, they used to task us to they create tunnels somewhere, they place objects which the robot must detect and avoid. So for it to detect that and avoid, they are the ultrasonic sensor, like that one the young kid is holding, the white one, that is an ultrasonic sensor. How does it work? It produces sound. When the sound is produced, it goes and hits on an object closer to it, and then that object reflects an echo. The echo is also, this sensor has two. One is for reflecting sound, another one is for detecting the bounce back or the echo. So using some algorithms, we are able to program the distance between this robot and that object ahead of it, which it is going to knock. That one, if you are dealing with if you're programming using Arduino, you will learn how to program ultrasensors to detect objects, and of course, once the object is detected, because we can accurately compute the distance between this robot and an object ahead of it using this ultrasensor, which is linked to the microcontroller, maybe Arduino or Raspberry Pi. Now, once that one is computed, you say, oh, this distance, maybe this object is like 1 meter away, meaning that if the robot continues, it's going to knock it. So what should it do? The command we put is that let the motors on the wheel make a turn left or right, depending on because we place these sensors at different points. Like we calculate what's the closest distance from the other one, and then we use the average to determine where the robot must turn, whether it should go left a bit. When it goes left and dodges, and just like a normal car, you dodge a bit, then you continue. So those are the physical devices. Sensors are important aspects of the robots. We have the ultrasonic sensors, the passive infra sensors. The passive infra sensors, which like these infra sensors in TV remote controls. The infra sensor in TV remote control, we usually put them under the robot to manipulate the motion. The surface where the robot goes is usually painted black and white. The black and white helps us to, because you know the infra sensor it has to detect the light intensity. Like if you have a TV remote control, you have a TV and a remote control. The remote control usually releases flashes infra light. That light is invisible to human eyes, but if you get your TV remote control and flash it on your smartphone camera, you can actually see that light. But if you look at it with naked eyes, you don't see it. So when you press your TV remote, you're flashing an infrared light, which is an invisible light. Then that light has that infrared sensor has also a receiver. It has a receiver on the TV. The TV receiver, the infrared receiver on the TV, definitely will detect the light, and you're able to control your TV. Now, the infrared sensor used on the robot has the remote. Has the receiver and the transmitter, the one which produces the light and the one which detects the light. They are all closer to each other, but how would it work? When you paint the surface where the robot is moving, that applies also to industrial robots. That's why even self-driving cars, their lanes have to be special designed, because they have to use the same principles to detect the surface, whether they're going off the lane or they are within the lane. I know they may be using more advanced sensors, but the basic principle starts from infra sensors, whereby we paint the surfaces, maybe let's say black and white, but it's not necessarily black and white. But why black and white? When that infra light falls on a white surface, it tends to have higher brightness because there is a reflection. Then when it goes on the black surface, the light intensity drops because the black surface absorbs much of the light. Now that helps us to manipulate the robot motion. If let's say the robot has to move straight and not be able to branch off, what we're going to on the microcontroller, we ensure that the light intensity coming from the infra sensor under it is kept high. That means it has to be placed on the white lane. So when the white lane is between the robot, it must be following that white lane, meaning that the light intensity will be high. Assuming that the robot is going off the lane, you have programmed to move, it is going to start moving on the dark surface and the light intensity will drop. Now what we are going to do is to manipulate, to program the motors, which are the tire controllers, to move the robot in the white lane, back to the white lane. So because these sensors are placed at different points, you calculate their average, then you see where the robot must go, whether it must go left or right. That's why it is able to turn accurately, it is able to reverse accurately, and basically from those principles, meaning that there's some sort of intelligence where we have to capture some sensitive information, and then we have to process it in a microcontroller, and then we command the motors. The same with the color sensors. The color sensors will detect the colors objects around it. Then if the objects have to be picked, and then there are servo motors on the robot arm, which must start moving the arm around, and it picks the objects. So that's one of the ways that physical robots use these multiple sensors, the ultrasonic sensors, the servos, the color sensors, infra sensors, and many other sensors to detect objects around. And then we manipulate the information. Basically, we manipulate the information using the microcontroller and direct the motors to make a decision. The motors are the one which now implement the decision by either, if it's a motor on the arm, mostly we use servo motors. The servo motors will start turning around, and the robot is able to pick objects. If it is these other motors on the tires, they will start making the robot either to reverse, to turn left, to move right, or something like that. So from that basic principles, those are the physical robots. But there are also now a lot of virtual robots. For example, nowadays you can visit websites, and the chatbots start popping up, and you have to interact with them. There's so many. They're good, most especially in areas where like universities could use them to assist students. Also, they can be used in big social networks like Facebook to help the community. So they are not having this, but of course, some may be using getting information from sensors, because our phones have sensors. The same sensors we use in these robots, they are on our phones. So they could be detecting your locations and many other things, and they ask you, the robot will, the chatbot will greet you according to your location. Maybe the sensors on your phone have already indicated that you're from Kenya or Uganda. Then the chatbot can ask you how is the weather in Uganda or in Kenya. So the sensors already within our devices. So the robot motion must be modeled, planned, sensed, actuated, controlled, and of course, motion behaviors are influenced by programming. So I just talk to you about that. I said for the robot, whenever you're going to start designing robots, you need to know the fundamentals. First, the electronics part of it. Knowing electronics is very important because you're going to start developing. I remember us, we had challenges building a power supplies. Not like the robots we used to build. You're not going to go to the market and buy one which is made to do that job, because the tasks that the committee in Nairobi are going to send us every year, they will vary. So there's no robot in the factory that is already made that can do that task all the time every year. So that means that every year they give us those rules in advance, what the robot we are going to design is going to do. Then we are able to sit down, we plan, we say, okay, this robot, they say it's going to be acting like a voter, mean that they are candidates, like presidential, there's the president, there's senators, there's governors, the MPs. So they're all, they don't tell us whether they're going to be tennis balls, but we have to imagine what they are. Then also, we say, okay, assuming those candidates are represented by tennis balls or by a certain object ahead of it, and they are painted at different colors, then what could the robot use to detect those colors? You say, oh, there's a color sensor. Now, the robot is going to use a color sensor to detect those different colors which are representing the candidates. Okay, now, because they told us the robot must start from somewhere, get a ballot paper, cross-check its name, whether it is in the as a registered voter, pick a ballot what? Paper. Now the ballot paper are those tendencies which it has to pick. So that means that there must be a robotics arm in that task. Then of course they give us other tasks like the robot has to pass through some tunnel as it is moving from one point to another. The concept of using the tunnel is to place it as an obstruction. If you do not use a sensor which can detect that tunnel, then the robot is going to knock itself on it. Then once we see a tunnel, we say, oh, there must be ultrasonic sensor which will sense the distance between that robot so that it can go through that tunnel without knocking it. And then they tell us the robot must climb. It is going to cast its vote. It has to climb a slope of 1 meter long and maybe 30 centimeters high. Most why are they doing that? Most robots these robots for student learning, most of them in the market cannot climb a slope. Most especially if it has a load, because your robot already has sensors, batteries, it has the robotics arm, it's already heavy. It cannot climb a slope. They can go on a smooth road, flat road, but when you task it to climb a 1 meter slope, many of it will not manage. But these people used to task us so that we don't just go and buy robots in the market and come and exhibit and claim that we made it. So we were tasked to develop robots with powerful motors that can enable it to climb, meaning that instead of having two-wheel robot, two-wheel means that you have robots where there are only two motors. Maybe the motors are the front. Usually can place, like this one, it has two motors, the one in front, which are maybe for, after, this one has four, but some people make just two. One, the behind wheels don't actually have motors. The front wheels have the two motors, and those robots are easy to program. But now when you place four motors on all the four sides, that means the robot could be that programming that robot to move forward, backward, left, right. There's some complex kind of manipulation of those those motors. Those four motors have to manipulate them using as we shall see how the ones for drones are manipulated. The one for the four-wheel drive cars, I may not explain it now until we reach to it somewhere where we're going to start talking about the drones, because there's a picture somewhere where the direction of the motors of the drones are shown. So that is we had to sit down and analyze that, and then we program all that. We put in the necessary software, sensors, the motors, and of course the battery systems, the battery power systems for such a robot. As you can see below where you see by Ezabo Baron, you see a small circuit there. That circuit is a very important circuit. That's a power circuit for the motors. Every robotics builder must learn how to build his own power system using basic electronic circuits like power regulator ICs. There are some special ICs for robotics, because the robotics motors, they try to draw in a lot of power. And some of these ICs, like power regulators, can easily burn. I don't exactly recall that, but once you start doing robotics, you can get that IC, which is used for programming the motors. It's 3 years since I last did those things. I can't remember the exact name for that IC. But because it can withstand higher power, because these batteries we put on these robots, like those robots we create, they might be having 4 motors for the wheels, then maybe another 4 or 5 for the servo motors, which are used in the arms. So at the end of the day, the robot is already consuming a lot of power, and you need a high capacity battery. Depending on the tasks, the battery must be able to last longer. Now, you can't just go and buy a battery in the market and come and plug onto the robot. You're just going to smoke the circuits because the current is so high. So what we had to do is to develop our own regulators depending on what we have designed. So one thing we learned in that project is designing also power systems. So that means you need to understand electronics. You need to understand programming. Programming languages, which we use mostly as C and C++. C++ is used for building the libraries for used in C, because challenge we got is that we used to go copy source codes from internet. You read some motor driver codes, you find them on internet, and you say, oh yeah, this one works for my robot. According to the task you're going to build, you may have to build your own libraries. I've never seen people building libraries, but when we were working on the robotics, we had to build them, because some libraries find on the internet are so complex, you don't really know where this person started from. So C++ is a good language that is used for building libraries, which are used in C. So knowing C and C++ is very, very important. That is if you're building a self-controlled robot, because the microcontrollers are designed using C and C++, except the Raspberry Pi, which are programmed using Python. But Arduino and many others, they're using C and C++. Then also, of course, if you're going into using mobile apps to control the robot, then there are, of course, already APIs for those robots, which you can now, robotics circuits, which you can use to integrate Java, because Android is running on Java. So if you're going to control your robot from a smartphone or from anywhere, then Java is also important, because you can integrate those using an API. Yeah. So in summary, you see, the motion of robotics must be modeled, planned, sensed, actuated, controlled, and the motion behaviors are influenced by programming. So programming is very important. C, C++, those are the fundamental languages for the embedded systems, for the circuits, for the microcontrollers. And then Java for any integrating with the mobile apps. Python, if you are using, of course, if also you are using web to control, Python comes in. Of course, you're going to link these languages using APIs. When you're in robotics, you'll get it. Those are the particular languages, but there are others depending on the microcontrollers you are using. But C, C++, those are primary. Java, Python, they are optional, depending on what you're going to do. Yeah. Then here, as you can see, there's a drone here. This drone now is from basic principles. It still has sensors. It has the motors. It can have 4 motors or more than 4. It can have ultrasonic sensors. It can have passive infra sensors, and many others. But the same principles from a mobile robot is the same you could find in a drone. But now the difference in the drone is going to be on the kind of motors used. The drone motors, especially, they have to be powerful enough to be able to lift the drone off the ground. And that one, it has to. So those motors are usually special motors, and they must be. Then once you have those kind of powerful motors, then the challenge is to have a battery system which can withstand all of them, because you need the drone to stay maybe in the air for a couple of minutes or an hour. So the battery has to really be strong, and that adds on it weight. And at the same time, you need to develop a power system in order to regulate. You have this high energy battery. Now you are developing a power system that can actually shrink it so that it can be used by the robot at a gradual pace. That is if you are going to build your own drone. But if you're not going to build your own drone, because there are a lot of drones which are already in the market, you just buy them and start programming. For fun purpose, you can build one from scratch. I've seen so many people building drones in Nairobi. But also on the other way, you can buy one and just focus on programming it. There are quite many drones currently sold in Dubai, in
Hello.
US. You can order them. Yes. So,
Hello, Ezabo.
yes.
We are still on the first page of your presentation. Maybe if you did move the reaction did happen in our head.
Oh, maybe I'm viewing on my phone. I can see the slides moving. Maybe you relog on your side. Is it the same problem, everyone? Because I've logged on my iPad and on the phone I'm seeing the slides moving. Maybe if there's another participant experiencing the same.
Yeah, the same problem.
Okay. So I should reload the slide. Can you see it now? Okay, let me stop sharing and I share again. So can you see it?
I am able to see it, but still on the first page.
Now what I need to do, I don't know, because me, I can see it on my phone, but let me send it for you on a WhatsApp, and then you upload it, you share it on a computer. Is that okay? Hello,
Yeah,
Chris.
it's okay. It's okay. You can share with me, then I'll share.
Okay. Okay, I've shared it on your WhatsApp. So you let me stop sharing the screen, then you upload it for me, then we turn them.
Okay, let me download. Is my screen visible from that side?
No.
I started sharing. Maybe I
It's
share.
saying starting to share content, but nothing is appearing.
Okay, it is now visible. I can see.
Oh, you can see the page.
Yeah, and then you can make it full. Can make it full screen. Okay, as we try to make it full screen, I think we are on that page. We're talking about this drone. This drone, as we say, that it's similar to the previous robot you saw in the cover page of my slide. Okay, it has gone off again.
I think there are problems. Let me check.
Okay.
I think it's okay now from your side.
It's not. Yeah, it has come now. You can make it. Okay, we are there. So I was saying that the drone uses some sensors, those ultrasonic sensors, infra sensors for motion manipulation, object detection, and all that. But of course, it is incorporated with the additional technologies like GPS, global positioning systems, to be able to navigate. Some have the cameras. It has cameras. Some have cameras attached to it. Some are remote controlled. Mean that there's somewhere someone is either using a mobile app to control the drone or a remote control. They are remote control specifically designed for drones. So it depends on what particular someone is using, either a smartphone app, a drone, a remote control, or it is flying on its own through the motion that was fed into motion algorithm that was fed into it with the aid of GPS, global positioning systems. So those are the some of the areas. Sensors are important, and also incorporations. If you are using a smartphone to control it, then you are going to need to know how to program it using Android Studio, something like that. The Java is very important. Let's move to the next slide.
Okay.
So, yes, here is a typical behavior of when you see this part where there's motor 1, motor 2, motor 4, motor 3. This is a basic motion manipulation technique for a drone. It is from this that you're going to be able to build any other complex drone. If you don't know this motion manipulation technique, it's very difficult to program a drone. The same applies to a mobile robot like the one you're seeing on the screen, like the car. That also, it has four motors around the tires. The motion manipulation techniques, I will hint you, but let's focus on this, the one for the drone. The drone, let's say this motor 1, motor 2, motor 3, motor 4 are motors like in the drone. You can go to the other slide, which is before this, where there was a drone. Yes, this one. So this drone has 4 motors. One we can't see, but we can see the other 3. But you can see that there are 4. There's one behind there. So you can go back. So let's imagine those 4 motors are represented in this diagram here. When you are going to program this drone, you see the position of 1. 1, the direction of motor 1 and the motor 1 and motor 4. No, motor 1 and motor 3 are flying in the same direction. Can you see that in the arrow, the direction of the arrows? Chris, can you see that motor 1 and motor 3 are moving in the same direction?
Yes, they are both clockwise.
Yes, but they are not. They are. Is it? I don't know that in mathematics, are they parallel? Are they perpendicular to each other? So you will expect motor 1 and 2 to be flying in the same direction. If you did that, the robot will not move. It will not even balance. It will just fall off because the resulting forces will overpower it and it will fall off. So that's why we call them rotors. Rotor 1 and 3, they must be flying in the same direction. That is the basic principle of a drone. You can attach your sensors, you can put the GPS, but if you cannot manipulate the motors of a drone, then the drone will never be in air. To be able to produce a lifting force, you have to at least manipulate the motors, which will fly, and then the resulting force will cause it to take off. That is what causing the resulting force is the one which lifts the drone off. So that comes from the manipulation of the rotors. So rotor 1 and 3, they are flying in the same direction. Rotor 4 and 2, they fly in the same direction. So let's assume that you want to take off the robot, you want to take off the drone. All the 4 motors will be switched on and they'll be flown at a high speed. They'll be flown at a high speed, and the resulting force will take the drone off the ground. You get it? That it will overcome the gravitational force, and the drone gets off the ground and is lifted in the air. Now, when it is in the air, you want this drone to turn around, maybe turn left, right, and manipulate in the air. Now, to do that, you are going to fly. Let's say you're going to fly motor 1. If you're turning, let's say on your right, you're going to fly motor 1 and 3 at a high speed. Then in motor 4 and 2, you are going to fly them at a lower speed. That way, the resulting force from a high-speed motor 1 and 3, they will cause the robot the drone to turn in the right direction. Then if you want it to turn in the left, you're going to fly motor 4 and the motor 2 at a high speed. Then you slow down the speed for motor 1 and 3. Then the resulting force will make the robot to turn in the left direction. Then there's that also manipulating them in order they can be able to just remain in the same position like a helicopter, in the same position in the air. That is still comes from the manipulation of the motors. Some may be flown at a higher speed, others are flown at a slower speed. Then the resulting force will cause it to either take off, to balance in the air, to turn left, to turn right, something like that. Then let's come into the mobile drone car, mobile robot, like this car here. It has four tires. Let's say those are motors in each. If you want it to go forward and backward, like you want it to go forward, the motors can be flown back, forward and back. You'll just you'll drive the motors forward. It will cause the robot to move forward. If you want it to go backward, you'll drive the motor in the reverse, and the car will go in the reverse direction. Now the complex part is when you want it to turn left and right. Similar to the way you were manipulating the motion of the drone, where motors are at different, they're like 1 and 3, they're moving the same direction, 2 and 4 are moving in the same direction. Then, if like you want to turn the mobile robot left, you could assume that you are going to let's say like you'll assume that you're going to move 2 motors, like the front motors, you're going to move them at a high speed. When move the front and then the back motors at a slow speed, but in the same direction, that won't work. The robot will just be moving forward still. Now, assuming like you moved the front motors at a high speed forward, then the back motors, you move them at a slow speed, but in reverse. The 2 motors front are moving forward at a high speed. The 2 motors behind are moving in the reverse, but maybe at a high speed or lower speed. The resulting force could make turn. Alternatively, you mix up the speeds. One motor from maybe the motors, the motors on the right side, 2 motors on the right side, you move them at a higher speed, but one may be moving forward, another may be moving backward in reverse. Then the other 2 move slower. One is moving forward, another one is moving in reverse. So the drone could be easy to manipulate, but the mobile robot, the motions, when their motors are like 4, the dynamics is quite complex. That is until you go into the circuit and start playing with the codes and see how they're moving, placing it here, testing it, until you find the best algorithm that you can use to move it forward and backward, or left, make it turn left and right. But integration of sensors, yes, there are some sort of difficulties, but without you manipulating the motors properly, then the robot won't move on forward. So that one you'll do more research once you start playing with these robots. I'll move to the next slide. So why is robotics needed? Robotics are very important in speed, and they can operate in very dangerous places. You see now these days military are using drones to go and carry out operations in places where humans could not go. Some are just sits in a remote area and controls it from there. Others move without human control, but most military drones they are controlled somewhere remote. So they're able to move without human control. Then there are those you could send in mining places. Maybe there are tunnels where humans could not enter. You could just send in the robots and they will be able to do surveillance or do any operations to either to rescue people in the mining which that had collapsed, and there are undersea robots which could go and pick people who have drowned or somewhere in the water. So there's this one used for irrigating farms, for spraying crops. The drones are now used for spraying crops in large farms where it will be hard work for humans. You can now you can now just set up a drone with fully installed with the sprays, and it is able to fly around the farm and spray against insecticides and all that. It can do repetitive work. Humans can easily get tired, but robots don't easily get tired. The accuracy is so high with the robots compared to humans. They don't get bored, they are not corrupt, they will not complain, they don't demand for pay. Yes, those are some areas, and they work so fast compared to humans. Go to the next slide. So robotics technology, there are quite a lot of technologies in robots, but basically robots, like they usually have the main body of the robot. It has the links, the joints, and other structural elements. Of course, like if a robot is going to be picking something, like those using factories, they have what they call the robotic arms. Those are what you can call the joints. Those arms are usually the combination of metalwork and servo motors. Of course, those which are using complex technologies are using mechanical gears. Gears are more. The gears are quite better often than electrical motors, for that they don't use electricity to operate. And second, they can withstand heavy weights. They can handle precise work, and of course, the other forces they use, like pneumatic, using air. Air makes them much lighter. Problems we face with these robots, they tend to be heavy, but air controlled robotics arms or actuators, they are lighter. You have seen caterpillars, they're using, of course, the tractors are using these. The tractors are using the arms, which are controlled using fluid, some sort of liquids, which are pumped forward and back. So those are in the industrial robots. They don't necessarily use motors, but they use gears, the camshafts, and all those kind of mechanical technologies to drive systems. But all in all, the principles are the same. Of course, somewhere there's an electronic system providing it the intelligence. That's why there's a term now which is commonly used in industrial robots called mechatronics. It's a combination of electronics, electrical, and mechanics plus computing. And then that is where you bring in mechanical technology, especially the physical robots. You bring in you bring in electronics, computing, and the electrical, and then they make up mechatronics. But if you entirely want to build it, I don't think that the mechatronics and the robotics, they just be terminologies which are interrelated, but there are some robots which may not go into complex mechanical physics. Yeah, but if you are going to work with the industrial robots, biomedical robots, definitely you will not avoid mechanical principles and the electrical control systems and all that. Because the controllers, you're not going to use Arduino in everything. Some are going to be using PLC, programmable logic control systems in that case, depending on what you're going to do. Then you can go to the next slide. Sensors, let me not forget to talk about sensors. You first remain there. Actuators, that's where I'm talking about mechatronics part of it. Some of you are doing electrical, electronics, computing, but when you go into robotics, you are going to be using so many skills. That's why as we had to work with the machining department a lot, electronics, machining, and electrical had to work hand in hand in designing our robots. Because the machining guys were the perfect, they are the one to see whether they're going to cut off the weight maybe by using gears or shafts. They are the one who understand that mechanics because they've studied more mechanical motions than the electrical electronic motions. So that's where actuators are found in these industrial robots to give it more strength and also to cut on the weight. Yeah, pneumatics is what we call the air, using air to control motion. And then hydraulics, using fluids. You can use water, but the viscosity of water is not so high. So there are special fluids. Like if you see these tractors used for constructing roads, those tractors actually using the same concepts. Because for them, they are not using actually a fuel. Someone just pumping fluids from one direction to another. That's why it is not taking a lot of fuel. But if it was to run on electrical engines, we would have expected to be using a lot of fuel. Yeah. So sensors are important. How much sensors you integrate, it depends on whether how much whether you're using electrical sensors, whether you're using mechanical sensors. Those are all important depending on the nature of robots you're going to build. So you'll have to read widely about sensors. It's not about just this. It's not just about the passive infrared sensors or ultrasonic sensors, but the other sensors which could work within. Pneumatic sensors, they are there. Hydraulic sensors, they are there. But they don't use any form of electricity. That is, if you are choosing to do industrial robots, then knowing pneumatics and hydraulics plus mechanical physics is very important. Servo motors, stepper motors, you will read more about that. Chris will share this slide with the participants and they read more about them. Okay, move to the next slide. So there must be processors in robotic systems. Processors, we are talking of the microcontrollers, which are going to detect, which are going to actually get intelligence from all these physical parts and be able to coordinate it. Obviously, if you are just using it for learning purpose, we always talk about Arduino. Arduino is always the simplest that you can use in schools. It's very simple. I can't say very simple as such, but affordable. It's cheap to get an Arduino board, and there are many in Nairobi. Then the other one is Raspberry Pi. Raspberry Pi is also, it has popularity in many things, but Arduino and Raspberry Pi, they go hand in hand. But every day, people tend to use more Arduino for smaller projects, but Raspberry Pi is quite wide. The application of Raspberry Pi is wide. And Raspberry Pi is using Python, Arduino is using C and C++. C++ is used for building expanding the libraries, and then C is used for just implementing the program. So knowing C and C++ when you're using Arduino, it's very important. But of course, that C and C++ has also been customized for Arduino. And also knowing how to code them in Arduino format of C is very important. And these are a lot of free resources on YouTube, on Arduino websites, on internet, just filled up with free resources about this. Operating systems, of course, let's say if you're going into industrial robots, you're going to start using other controllers. We know of the PLC, programmable logic controls. You're going to, there are some industry controllers which you are going to also be using. So you have to research widely about, but you start with Arduino, Raspberry Pi, then move into those complex controllers. Software operating systems, I can't particularly talk particular one, but if it is for modeling, because sometimes you may not have money to buy those physical equipment, by the cost of some money, buying those sensors, buying those microcontrollers and fabricating the chassis and all that. But you may want just to start playing with the codes and the virtual simulators. Now people are using MATLAB. MATLAB has Simulink. It is for Simulink has a library for robotics and many other mechanical applications. If you use Simulink, MATLAB Simulink, you are going to be able to actually even program industrial robots where you could not even own one. Simulators are very good. Most person, if you're maybe your work we are doing now, you want to start experimenting with the advanced robots. Then we also have one other, let me see which one. Yeah, there's a particular operating system called ROS, Robotics Operating System, ROS, ROS. ROS is the robotics operating system. It is also, it's not an operating system, which really, but it's a simulator which you can use to simulate many of the robotics tasks, including even working with the advanced computer vision. So those simulators are very good. They help you if you will not be able to have money to buy to buy all those things, or to even to build up your own robot from scratch. So you could use MATLAB. MATLAB is big pack. It's a big software, but it has frameworks like Simulink, which can be used for robotics simulations. Then there's the ROS, Robotics Operating System, which you can also use to simulate robotics. Yeah, moving to the next, we're about to finish the slides. I know we are maybe about 10 or 15 minutes, yeah. So we talked about different types of robots. We talked about mobile robots. It could be simple robots. Mobile robots, they're able to drive around. We have industrial robots. Industrial robots, they could be stationed in one place, or they are able to pick packages from one place to another, or they are just stationed fixed in one place. They have robotics arms used for manufacturing cars, solar panels, complex things. So those are industrial robots. Autonomous robots, we talked of undersea water robots, those used by marine to go for wars, to monitor, to surveil, to do research, to rescue. These robots, they may be controlled remotely using a GPS. Maybe, or they can navigate on their own. There are those drones they're using for surveying, for delivering emergency products like medicine, as you've seen in some of the East African countries where they're used. I know now you have Konza project in Nairobi, where you're planning to use many of these autonomous robots in the city management. Remote controlled robots, those which can be controlled remotely. Virtual robots, I talked of virtual robots, those virtual assistants where you don't have a physical robot, but you could have softwares programming fully intelligence to be able to serve communities online. There are those which are now using by telecom companies to respond to customer queries and many other things. No, because we are using digital technology to enhance businesses. So robots have very many applications, yes. Now it depends on which one you are going to do. Where are you going to start with? It is easy to start with simple mobile robots and virtual robots, maybe remote controlled robots. Then, but when it comes to industrial robots, you will have to start maybe with simulating with the MATLAB or those ROS operating system, robotics operating system. or you may join, if your university has already the facility, you join the research group. You can join the mechanical department or whatever, electrical department, electronics. You know, if you're in computing, it's good to integrate with the other departments so you get to know. And when it comes to working with the circuits, you may need knowledge from guys from electrical, guys from electronic, guys from telecom. When it comes to working with the physical parts, need the knowledge from guys from machining, from mechanical engineering, something like that. So it's a multidisciplinary project. For us at Nakawa, there are 7 departments. Whenever we're designing our robots, we work with all those departments, the plumbing department, welding department. How would you say that plumbing department will not be part of you? Actually, I learned how to automate pneumatics and hydraulic systems through a project which is running under plumbing department. They have a water automation department which was set up by GIZ German. And it is whereby I learned how hydraulic systems are automated, how the pump systems are controlled, all those things. Then when it comes into electrical department is where they teach about control systems, the relay sequencers, the PLCs. They are basically taught in electrical departments. And then, of course, the guys from electronics, computing, they're good in things like digital circuits, digital ICs, and all that. So interrelating is very machining guys. They're good in these things of welding, fabricating, manipulating mechanics. They are very good in that. So you work in interrelation to other departments. We are working with this, but in simplest term, start with MATLAB, start with Arduino, start with the Raspberry Pi. Okay. Move to the next. So here we can see a simple mobile robot. It has in front of it something looking like an eye. That is the very important sensor that is called ultrasonic sensor. It has two sensors. One is called echo. It produces a silent sound. And the next one is the receiver. When the one which produces echo, the echo will go and bounce on some object which is closer. Then the receiver will receive it and transmit what it has received as an electrical signal to the microcontroller. Then we're able to read the values which we are receiving through the echo. And we are able to manipulate the tires based on the values we are receiving. If the object is, let's say we set our threshold, we say that the object should never come closer to, the robot should never come closer to an object at a distance of 30 centimeters. Once it detects an object in the range of 30 centimeters, we need to command the tires to make turns, to turn left or to turn right. And then when it turns, it has to pause for some time, maybe it drives for microseconds, then it regains back its path. Depending on it, we can place these ultrasound sensors at different points, and then we use to compute the surrounding of the robot. Yeah. Then and there you can also see industrial robots, which is like a complex arm. This one is having complex mechanical. You can see there, you see like a sort of a wire running through this metal. It has some sort of three pipes, small pipes. Those could be for pumping air. It could be a pneumatic robot where the motion is controlled by air, movement of air. That is what they call pneumatics and hydraulics. And that topic is much covered if you are dealing with guys working with the water, studying water or fluids. That's why I say in Nakawa, I learned it in guys from plumbing department, where I received the training in that. Then also guys from machining department will do it. Now, if it's in university, guys from mechanical engineering, I understand that one. You work with guys from mechanical engineering, but there are a lot of resources online talking about pneumatics. The topic generally is called fluid power. Fluid power, if you go to YouTube and type fluid power, you're going to learn a lot about pneumatics and hydraulic systems. You will realize even you may get lost there and you start looking at the more complex. That's good for industrial robots. But if you are working on these robots on our right, I mean the mobile robots, then more knowing electronics, programming and the electrical basics is more important. But as you move into more complex robots, you have to integrate. That's where the idea of mechatronics comes in. Yes, going to the next slide, we're about to end. Then we get some time for questions. We talked of rolling robots, walking robots. Now there are so many robots. The Sophias are walking robots. The popular Sophia robot. They have legs, you know, they can move. There are quite many of them. Rolling, these ones, it's just drive on ground. They're flying robots. So this is what we are talking about. You can go to the next slide. So remote control robots, these robots, as you can see, the drones which are used by military to fight, to bomb everywhere, they are using remote controls. Someone sitting at command center to monitor. The drones you'll use for monitoring Konza City, Nairobi City, they are going to be remote controlled. Someone will sit somewhere in the control center to monitor their movements, cameras attached all over it, sensors, and all that. So those are remote controlled. They can be able to perform complicated tasks which humans would not easily be able to operate. Yes. I think we are reaching to the last slide. You can go there and then we have time for questions. So also search engines use virtual robots. This is easier to start with. Since you guys, most of you are from computer science, this is a project that you can start, like building chatbots. Search engines are using all this. You see nowadays you could just feel lazy and you get your smartphone and you want to search anything on Google. You turn on your voice, Google Voice, and you speak. Say, Google, what is it? Where is which continent is Kenya found? It will tell you Kenya is found in Africa. Google, how many countries are there in Africa? It will tell you around maybe 50. I don't know the exact number, but they're like 50. It will give you the exact result. That's now a chatbot using search engines. It's integrating with your phone's microphone. That's why I'm saying still working with the sensors within your phone, the inputs within your phone. So you have the microphones are there, the GPS are there, the accelerometers are there on the phone. So you could start by developing apps which are in form of virtual assistant robots. And that has a wide application. These are something we can start with zero cost because we already have computers, you have smartphones, you start developing an app. As you wait for those Arduinos or the Raspberry Pis, you can start with your phone and your computer, build the virtual chatbots, and it has application. Yes. So I think with that, the topic is really so wide, and robotics is just a subset of an artificial intelligence technology. And of course, it depends on whether you're on physical robots, whether you're on virtual robots. Virtual robots could just start projects with your smartphone and your computer and build apps that can act autonomous, that can help humans. We have, let me say, we have apps which are used by these disabled people. Let me say, for example, those who of course, people are using them for translating languages. Like if I went to Nairobi and I am not fluent in Swahili, there could be an app developed either by Ugandan developers or Kenyan developers, which could enable the Kenyan people to speak in Swahili. And then me, who don't, because in Uganda we don't speak Swahili so much, I could be able to understand Swahili in English or in my local language, either in Luganda. Then I also speak back in Luganda or in English, and you're able to hear it in Swahili. So this is also a good way of developing virtual assisting robots to help everyday community. People have developed sign language translators. Like you're talking to disabled people who are using sign language, and you don't understand the sign language. The robots which they've built, they can help you translate sign language into your normal language. And when you speak back, it could also translate, the app could also translate what you have spoken into their sign language. So that it makes it easier for each person to communicate to each other. So these are one areas where you can use these virtual chatbots, but the ideas are quite many. So with those few remarks, I think it's already coming to 5:30. Let's have some time for questions. Thank you.
Okay, thank you. Thank you, Ezabo, for that. Maybe if you have a question, you can unmute and ask the question if you unmute and ask. Okay, I see there are no questions. Seems that the session was very clear. I also feel that everything was clearly highlighted. Thank you, Ezabo, for that. Maybe next time we'll just have a hands-on session where we'll have to write the code and build systems. Hello, Ezabo, you have something to say?
Yes, thank you so much, Chris. Yes, that's possible. Yeah. Since now, I think by next year, early next year, Uganda is going to open up its borders. I really like coming to Nairobi. I used to visit before COVID. I will visit Nairobi nearly 4 times a year. But now, once things get well, we'll be able to come to Nairobi, we'll be able to come to Uganda, and we do some of these things hands-on. I know of, I don't know, because now in robotics, many of the people who usually work with hardware, they tend to switch to other, like mostly they become mostly software project developers. And of course, usually we don't want to make things from scratch. We try to leverage existing systems. Like if you're building a vehicle monitoring system using GPS, you will not want to start building that circuit from scratch. You will just want to buy what the Chinese have made and focus on coding. Same applies to some projects involving drones. You may not want to fabricate them from scratch. But there is a company which is in Kenya. It's called Numerical. It's called Numerical. Numerical IoT. Let me check on them. Numerical IoT Kenya. I can tell you they are real good when it comes to these things. Yeah, they are called Numerical IoT, electronic design and manufacturing. When it comes to things like drones, they have really made them from scratch. It's just a young boy who started it in Kenya. I don't know if you have ever heard of it. They also make these speed limiters, speed guards. Have you ever heard of Numero IoT, a company in Kenya?
Yeah, yes, I guess personally I've heard of it.
Yeah, I think these guys are really good when it comes to, I think they are really championing it. They are just young guys, but they really have the brain. I admire what they do. They are good in hardware, software. I think they have a full electronics factory now. And they recently built up their vehicle, a bus. They call it party bus. Fully installed with the electrical systems and all that. They built it from scratch. So I think if there's anywhere you want to get into, but of course, since they are commercial companies, now they're focusing on their research. You have to also first start with the fundamentals somewhere, then you can move into them when you already have enough knowledge. There's a company we used to deal with, it's called Nerocas Engineering. It's also in Kenya. I don't know if you've heard of Nerocas. They're based in the Thika district. Nerocas is the one which sells it. I'm going to forward, Chris, I'm going to forward for you their contacts. You can share with the participants. I'm just going to share with you their website. Nerocas, when it comes to the components, they're the one we used to buy components from. All our components are coming from Nairobi, and they can link you with the other guys. There's another shop. It's in Nairobi, in downtown near Kampala Bus Park. It's called the Massimo Electronics. I don't know if you've heard of it. Massimo Electronics, Nerocas, Numerol. These are the best place I will recommend for you when it comes to getting into these things of, because I know problem people face getting hardware, the parts and all that. For us in Uganda, we'll get them from Kenya because ordering them was difficult. But we used to deal with the Massimo Electronics and the Nerocas Engineering. Thank you. I just encourage you start working with your virtual chatbots because you have a phone and a computer, start developing something. Thank you for that.
Okay, thank you, Ezabo, for that session. That was a very informative session. Also, thank you all the participants who have stayed with us till the last minute. The session was recorded and the site was shared, so I'll be sharing them tonight. Yeah, so I would like to invite Alex to give us final remarks as we closes the meeting. So, Alex, what will you remark?
Okay, thank you, Chris. Thank you for setting this up. Ezra, thank you for your good presentation. We look forward to more sessions as this. Members who joined, I can see Alan, Danny, Petak. I can't see everyone, but thank you all for joining us. We'll continue having this kind of sessions, and we build the IEEE in the region. Now at the end, Ezabo mentioned about IoT. There is actually going to be an annual IoT conference that IEEE Kenya will be a partner. This year it went a bit fast, but from next year we are going to be having a regular IoT competition where you can even, if your project does well, you can even go to present it in Dubai. So be on the lookout of that. And at least you have started early. So I don't know if Ezabo, one day maybe even you can have a session specifically on IoT.
Yes, I can have a session on IoT, and also we are part of that. This year, Uganda participated in Uganda. That program is headed by UTAM University, but I'm one of the committee members since I'm the chair. So I'll be able to work, present on that.
Okay, so there's a lot of things we can do together and help everyone. But thank you for being part of this, and we welcome you to also join future sessions. Thank you, Ezabo. Thank you, Chris. Thank you, all participants. Back to you, Chris.
Okay.
Thank you. You can just leave your own patient. Thank you. Have a good evening and a good night. Good weekend too.
You too.